Hello, let's discuss the important formula of states of matter. This is part 1. Already in part 1 is mentioned. This is part 2. Payload is one important concept that you have to know. Payload is simply I'm writing as PL. Payload is equals to actually when you are filling a balloon with some air which is lighter than normal air, that is if you are filling with hydrogen or helium, that is going to displace some air. So how much of air it is displacing, that is called as payload. So payload is equals to mass of air displaced, mass of air displaced by balloon minus mass of balloon plus air filled in it. The mass of air filled in it. If you take the sum of these two and subtract from the mass of air displaced, then you can find out the payloads. Based on this, there is a chance of getting questions. Then kinetic gas equation. Kinetic gas equation is PV is equals to 1 by 3 mnc square, where P is pressure of the gas, V is volume of the gas, m is mass of each molecule, n is the number of molecules, c is the RMS velocity. Then types of velocities will take types of molecular velocities. The first one is RMS velocity. Root mean square velocity, it is given by C. C is equal to under root of 3 RT by M, where T is absolute temperature, R is gas constant. R value you have to use 8.314 into 10 power 7 egg per mole per Kelvin. When you use this one, then only you are getting the RMS velocity in centimeters per second. Fine, remember you have to use this value. RC is equal to under root of 3 PV by M. RC is equal to under root of 3 P by D. All these you can use according to your wish. Then average velocity. Average velocity is given by C bar. C bar is equal to under root of 8 RT by pi M. C bar is equal to under root of 8 PV by pi M. C bar is equal to under root of 8 P by pi D. These are the important formulae for C bar. If you want to calculate C bar, then use C into 0.9213. This is the conversion factor. Or C if you want C bar into 1.085. These are the conversion factors. And another velocity is most probable velocity, which we call as simply we can show with C most probable velocity, the velocity possessed by the maximum number of molecules. Cp is equal to under root of 2 RT by M. Cp is equal to under root of 2 PV by M. Cp is equal to under root of 2P by D. Right? So the conversion factor is Cp is equal to C, that is RMS velocity, into 0.8166. Or C and Cp, another relation you can take, C is equal to Cp into 1.224. This relation is asked in 2 years back. Cp is to C bar is to C, that is equals to 1 is to 1.128 is to 1.224. This question was asked in 2014 JEE mains, if I am not wrong. Cp is to C bar is to C is equals to 1 is to 1.128 is to 1.224, 2013 or 2014. So this type of questions also you can expect in exams. Fine. Then kinetic energy is equal to 3 by 2 nRT, where n is number of moles, T is absolute temperature, R is gas constant. R by n is called small k. This is called Boltzmann constant. K is called Boltzmann constant. K values are 1.38 into 10 to the power of minus 16 erg per molecule per Kelvin. Or you can say 1.38 into 10 to the power of minus 23 joule per molecule per Kelvin. This is not mole, this is molecule. As place is not sufficient, I am writing m. Joule per molecule per Kelvin. At same temperature, if temperature is same, you can write RMS velocity formula as C1 by C2 is equal to under root of M2 by M1. This is very similar to Gram's law. R1 by R2 is equal to under root of M2 by M1. For same gas, if the gas is same, that means molecular mass is going to be same, then C1 by C2 is equals to under root of T1 by T2, the relation between the velocity and temperature. Same velocity if they are asking, then C value is going to be same, then the formula is T1 by M1 is equals to T2 by M2. There is no square root, note this point. Fine. Now compressibility factor is given by Z. Z is equal to PV by RT. Z is equals to 1 for ideal gases. The gas is ideal gas, Z is going to be 1. Okay. Then some graphs I would like to introduce. The graphs PV versus P. See carefully. Here Z is equal to 1. And this line indicates hydrogen gas. This line indicates helium gas. And a line here nitrogen gas. And a line here carbon dioxide gas. Hydrogen is and helium both are always above 1. They are not very less compressible gases, very tough to compress. And nitrogen and carbon dioxide gases are slightly coming down, they are going up. That means at low pressures we can compress them. Z is equal less than 1 means we can compress the gases. PV versus P graph we are taking. Z is equals to 1 means this is for ideal gases. Hydrogen and helium always showing positive deviation. Nitrogen and carbon dioxide showing negative deviation initially, then after at high pressures they are showing positive deviation. So the gas which is coming more down, that can be easily compressible. In these two gases, that is nitrogen and carbon dioxide can be compressed easily or liquefied easily than nitrogen. In hydrogen and helium, hydrogen is tough to compress. Okay, hydrogen is above this. So this is PV versus P graph. Another PV versus P graph I would like to give. You can see here the deviation is more, here the deviation is little less, here the deviation is very less. This is a temperature T3, this is temperature T2, this is temperature T1. So at high temperatures the deviations are less. That means the gases behave like ideal gases, or the gases show ideal gas behavior at high temperatures and low pressures. We can see in this case here the in T1 case the deviation is more, in T3 case the deviation is less. Fine. Then reduced temperature formula is, reduced temperature is given by TR, this is equals to T by Tc. The same way reduced pressure PR is equal to P by Pc. Reduced temperature T by Tc, reduced pressure P by Pc. The Van der Waals equation is one of the very important points. What is Van der Waals equation, how it is written, and based on some questions. The PV is equal to nRT is called ideal gas equation. This ideal gas equation, how it is changed to Van der Waals equation. P plus A by V square into V minus B is equal to RT. This is called van der Waals equation for 1 mole. P plus AN square by V square into V minus NB is equal to nRT. This is known as kinetic gas equation, sorry, van der Waals equation for n moles. Then excluded volume for one molecule. This is important point. Excluded volume for one molecule is 4V. Remember this point. 4 times of volume of the one rest molecule, that is considered as excluded volume of molecule. Excluded volume for n molecules. N means here I am taking as 1 mole. N molecules will be N4V. This is simply we call as B, van der Waals constant B. Okay, so this point you remember, excluded volume for the n molecules will be N4V or 4NV, that is equals to B. In van der Waals equation, we have A and B. The units for A are van der Waals constant A are atma liter square per mole square. Atma liter square per mole square. Units of B are liter per mole. Remember, these units are important. They can be directly asked in exams. Then Boyle's temperature is Boyle's temperature is given by TB. TB is equal to A by RB. Then inversion temperature is given by TI. TI is equals to 2A by RB. This is double of Boyle's temperature, 2A RB. Mean free path, the molecule moving between the collisions, within two successive collisions, whatever the molecule they are moving, that is called as free path, and average of that is called as mean free path. Mean free path is given by lambda. Lambda is equals to eta under root of 3 by PD. This is called viscosity coefficient. Viscosity coefficient. Viscosity coefficient. Then the critical terms VC is equal to 3B. The critical term TC is equals to 8A by 27 RB. VC is equal to 3B, TC is equal to 8A by 27 RB, and PC is equal to A by 27B square. If you take all this, RTC by PCVC is equal to 8 by 3. Remember these formulas, that may be useful to you. So some more are remaining, we'll go with those. The van der Waals equation, you can write this van der Waals equation in different forms at different conditions. For example, if you are taking at low pressures, when the pressure is low, the volume is going to be very, very high. Then the B term will become negligible. When B term is negligible, the van der Waals equation will become P plus A by V square into V is equal to RT. I have removed B from here. Then this becomes PV plus A by V is equal to RT. PV plus A by V is equal to RT. Or when you divide all these with the RT term, PV by RT plus A by VRT is equal to RT by RT. PV by RT is called Z. Z plus A by VRT is equal to 1. Or you can say Z is equal to 1 minus A by VRT. This is the expression. This is also asked in JEE mains. At low pressures, at high pressures, how the equation can be written. Just this is at low pressures. At high pressures, when the pressure is already high, there is no need of A by V square time. A by V square is now negligible. There is no need to discuss about A by V square. This I am not taking. Then the equation will become P into V minus B is equal to RT, or PV minus PB is equal to RT. Divide all these by RT. So it becomes Z minus PB by RT is equal to 1, or Z is equal to 1 plus PB by RT. Z is equals to 1 plus PB by RT. So this expression is at high pressures. So this you can expect in JEE mains type of exams. The Poisson's ratio is given by gamma. Gamma is equal to Cp by Cv. For monoatomic gases means like noble gases, Poisson's ratio is 1.66. For diatomic gases, gamma is equal to 1.4. And for triatomic gases, gamma is equal to 1.33. Monoatomic, diatomic like O2, N2, Cl2, triatomic means like SO2, NO2 type of gases. For monatomic gases like helium, neon, argon, Cv is equal to 3 by 2R and Cp is equal to 5 by 2R. See carefully, helium, neon type monatomic gases, Cv is equal to 3 by 2R, Cp is equal to 5 by 2R. For diatomic gases like oxygen, nitrogen, chlorine, for all these diatomic gases, the Cv is equal to 5R by 2, Cp is equal to 7R by 2. There that is 3R, 5R, here it is 5R, 7R. For triatomic gases like SO2, NO2, the Cv is equal to 6R by 2, the Cp is equal to 8R by 2. Okay, fine. And finally, last one will take the Clapeyron equation. This equation you can use in different topics. Clapeyron equation. This equation gives you the relation between two different pressures and temperatures. Log P2 by P1 is equal to delta H vaporization by 2.303 R, here 1 by T1 minus 1 by T2. 1 by T1 minus 1 by T2. Or you can write log P2 by P1 is equal to delta HV by 2.303 R into T2 minus T1 by T1 T2. Fine. Okay. So these are the important formulae. You can comfortably go through with this, and if you find any doubts, you can WhatsApp me on this number. I will try to clear your doubts. Okay. So this is your Lakshma Reddy signing out.